Welcome back to this series of conversations at the Dark Reading News Desk at RSA. Terry Sweeney here with Dark Reading, and joining me now is Ayal Yogev, CEO and co-founder of Anjuna. Ayal, thanks for joining us today on the news desk.
Thanks for having me.
You are a proponent of a security model known as confidential computing. For those who are new to it, tell us a bit about what it is, how it works, and how it distinguishes itself from other models.
Sure. So confidential computing is essentially this new technology that was added by the CPU vendors. Essentially, it's the ability to run things completely confidentially, completely privately on top of any infrastructure. And you can, some examples are, cloud or, geographies that you might not trust. And this technology essentially allows you to do that.
It sounds like it's done in an isolated way that prevents eavesdropping, interception, those kinds of things.
Exactly. It's an interesting story how it started. I don't know if you ever thought about, what happens if you lose your phone. You have your, fingerprint or Face ID, biometric data that is extremely sensitive. And, does that mean that somebody can get access to that data? What essentially it started sort of on the phone, what the CPU vendors have done there is to make sure that even if you lose your phone, that data is so protected that even physical access doesn't give you the ability to see it. What then sort of happened is on the server side, the CPU vendors have done the same. They've added these capabilities on the server side, which is obviously extremely valuable to essentially give you the same level of capabilities.
In that vein, help us understand the difference between homomorphic encryption and confidential computing.
Yeah, so at a very, very high level, they're both trying to solve the same problem, right? Essentially, how do you process data in a way that's completely secure? So even, so any type of access is not going to have access to data while it's being used, which has always been one of the biggest problems in security. The big sort of difference is homomorphic encryption is done completely in software. Confidential computing requires the hardware underneath, but then homomorphic encryption has a pretty significant performance impact, which sort of makes it unusable for the general use case. Confidential computing, now that it's part of every CPU that's being shipped, now that it's supported by every cloud, can be used essentially for anything without the performance impact.
Ayal, confidential computing leverages enclaves and creates something called trusted execution environments where workloads and tasks can be isolated from unauthorized use or access. Can you say a bit more about how those work?
Essentially, what this technology allows you is to completely isolate, code and data from anything running on the machine. Enclaves is one technology that enables you to get to confidential computing. What it allows you to get to is a trusted execution environment. How do you execute, code in a way that's completely trusted, that's happening on the machine? It's actually interesting because of some of the protocols in blockchain now require a trusted execution environment to be executed, and we're seeing a lot of companies in that space starting to implement those. Essentially, how it works is that the hardware itself provides you with an isolated, again, the different hardwares work a little differently, but essentially they provide an isolated memory space so that even if you have root access or physical access, you can't access that memory space, only the application itself can access it.
So I get that this is happening within the silicon. Why is silicon needed to deal with confidential computing? And what are some of the challenges there?
Perfect, that's a great question. So essentially you need sort of the hardware, the silicon support, because without something sort of rooted in hardware, it's going to be very, very, you can sort of bypass almost any software solution in terms of security. You need something rooted in the hardware to make sure you get that level of protection, that even physical access, even root access doesn't give you access. Okay. But the big challenge though is, and that's to some extent, what my company does and other companies in the space is, these are extremely low-level technologies. So if a customer or an organization wants to go leverage these technologies, they have to go and rebuild their entire software stack to go leverage these very, very low-level technologies. It's all similar to some extent, every time there was a big architecture shift on the hardware side, there was a software stack that was built on top of it to make it simple to use and ubiquitous. We've seen this with Microsoft and the CPU. You need an operating system to use the CPU. Same with virtualization and VMware. It was extremely powerful technology, virtualization, but we needed the VMware to make it accessible. This is sort of what's happening now with confidential computing. It's a set of hardware technologies, and what we do is we provide a software stack on top of it to make it super simple to use and ubiquitous across the different technologies.
With that in mind, will we need to replace servers and end devices, or does this become transparent, say, inside the cloud, for example?
So inside the cloud, it's now completely transparent. The clouds have all adopted
Okay.
these technologies for basically two reasons. One is, as I think we all know, security and privacy is the top reason why large organizations are hesitant about moving their sensitive workloads to the cloud. And what the clouds have done is they've added these technologies to be able to turn to their customers and tell them, when you use confidential computing, we, the cloud vendor, don't have any access to your data. It sort of breaks that shared responsibility model that the clouds talk about and customers don't really like. So that's one reason. The other reason is that it allows the clouds to turn to the government and tell the government, you can't subpoena us because we don't have any access to our customers' data.
So effectively, you have a secured container in the cloud to run these workloads or other operations.
Exactly. The clouds, the big sort of benefit of the cloud is somebody else is managing your infrastructure, but then there's a security cost to that, because if somebody else is managing your infrastructure, then they can have access to everything that you do. This breaks that. This means that you can leverage the cloud, get all the benefits of scalability of the software stack that exists in the cloud, but without taking that security risk of having somebody else managing your infrastructure because they don't have access to anything.
Let's talk a little bit more about the cloud. The cloud security, just with a single provider, is a challenging task. To complicate it, most users end up with multiple cloud vendors.
Yep.
So the coordination of security management among multiple cloud providers is a challenge that's beyond most security workers and executives, it seems. With that in mind, I mean, how do you see this changing the nature of cloud computing, where this multi-party service delivery model creates gaps that are, it seems like, impossible to fill?
Yeah, that's a great question. That's to some extent, this is exactly part of the value here, is that once, kind of like when you use virtualization, you don't really care what's the sort of the CPU underneath because you have virtualization. This is the same type of thing. Once you have this layer of being able to run anything securely on top of any cloud, it sort of obfuscates the cloud to some extent, and you can leverage a multi-cloud environment in a secure way without having to kind of tie yourself to the different security services that each cloud has. So yeah, it definitely is a right step in that direction. And we see more and more customers that have to be multi-cloud for multiple reasons. One is the large companies go and acquire other companies, and that makes them multi-cloud even if they try to be on one cloud. And then a lot of industries are starting to get regulations that force them into using multiple clouds.
Right. What are some of the early use cases that you're seeing for confidential computing?
Yeah, what we see is I guess the big one is cloud migration. It's we see either large organizations, think financial services, healthcare, oil and gas, or governments are trying to leverage the cloud, but security is a blocker for them. So in some cases they start moving things to the cloud and they get stuck at some point with sensitive data, and this enables them to move more data that they couldn't move to the cloud without this. We also, so this is one use case, we see a geographical expansion as another one, with companies that want to run code. Think of American companies wanting to run code in China because they're expanding into China, or European companies wanting to come into the US but have privacy challenges around things like GDPR. This essentially unlocks that geographical expansion for companies. And I'd say the third one that we're seeing is with ISVs, with software vendors. And what confidential computing essentially enables them to do is to go and tell their customers, we're running inside of confidential computing, so we and our employees don't have any access to your data, the customer within our platform. So that essentially enables them to provide better security and better privacy for their customers.
Ayal, lots of great upsides to confidential computing. Thanks for doing this today.
Thanks, Terry. It was a pleasure.
We've been talking with Ayal Yogev of Anjuna. This has been Terry Sweeney for the Dark Reading News Desk. Thanks for joining us today. We'll see you next time.